Artificial intelligence, AI, is fundamentally transforming agriculture, offering solutions to critical challenges in food security, resource efficiency, and environmental sustainability. The United Nations Food and Agriculture Organization projects a 70% increase in global food production is needed by 2050 to feed a population of 9.7 billion, with 50% of Earth's habitable land already under cultivation. Agriculture faces additional pressures from labor shortages, with a 22% decline in U.S. farm workers from 2000 to 2024, as reported by the U.S. Department of Agriculture and Climate Change Impacts, with the Intergovernmental Panel on Climate Change documenting a 28% reduction in global crop yields due to extreme weather events since 2015. AI technologies, including precision farming systems, high-throughput phenotyping, and language models tailored for small-scale farmers, are driving unprecedented efficiency and inclusivity. Looking forward, integration with quantum computing, synthetic biology, and advanced robotics promises to further revolutionize agriculture, though environmental costs, ethical concerns, and equitable access remain critical considerations for sustainable adoption. Precision agriculture leverages AI to optimize resource use through advanced tools like autonomous weed control systems. A prominent example is Verdant Robotics technology, which integrates 12-megapixel cameras, convolutional neural networks, and LiDAR sensors to achieve 98% weed detection accuracy in 2025 field trials across diverse crops like broccoli and lettuce. Mounted on tractors, these systems deliver herbicide doses as precise as 0.07 milliliters per target, reducing chemical use by 87% compared to conventional broadcast spraying, according to a 2025 study by the International Society for Precision Agriculture. This precision mitigates pesticide runoff, which the Environmental Protection Agency identifies as contaminating 78% of U.S. waterways. Operators monitor AI decisions via real-time dashboards, achieving a 38% reduction in labor costs for weed management, per 2025 Agritech Analytics data. Beyond weed control, AI-powered drones and autonomous tractors, such as John Deere's 8R series with See & Spray Ultimate, integrate multispectral imaging and IoT sensors to monitor soil pH, moisture, and crop stress, enabling interventions that boost yields by 22%. John Deere's roadmap to fully autonomous farming by 2030 is advancing, with 35% of 2024 equipment sales featuring AI-driven automation, reflecting a 30% annual adoption growth per Agritech Market Insights. In Europe, similar systems by CNH Industrial have reduced fertilizer use by 25%, supporting the EU's Green Deal targets for 50% pesticide reduction by 2030. AI is revolutionizing crop breeding through high-throughput phenotyping, where machine learning models analyze multi-dimensional datasets to identify optimal plant traits. At the University of California, Davis, researchers employ hyperspectral imaging, capturing 600 light bands to generate datasets exceeding 15 terabytes per trial. In a 2025 trial of 450 maize genotypes, AI identified traits like drought tolerance and nitrogen efficiency, reducing breeding timelines from 25 years to 2.5 years. This is critical as climate models forecast a 22% yield loss by 2035 due to water scarcity and heat stress. AI-driven breeding supports sustainability by developing crops requiring 35% less water and 28% less fertilizer, aligning with the 2030 Sustainable Development Goals. For instance, AI-bred rice varieties in Southeast Asia increased yields by 18% in 2025, per the International Rice Research Institute. By leveraging deep learning to predict genotype-environment interactions, these models enable farmers to adapt to regional climate variability, with 2025 data showing a 17% yield increase for AI-optimized wheat in arid zones of Australia and the Middle East. For small-scale farmers in regions like South Asia, Sub-Saharan Africa, and Latin America, AI delivers inclusive solutions to enhance productivity. AgriChat, a large language model developed at UC Davis, provides hyper-local advice in 180 dialects, incorporating speech-to-text and text-to-speech for low-literacy users. In 2025, pilots across India, Kenya, Nigeria, and Brazil, AgriChat increased smallholder yields by 15% by recommending climate-adapted crop varieties and pest management strategies, integrating data from NASA's Soil Moisture Active Passive Satellite with 92% accuracy. Unlike generic AI models, AgriChat uses colloquial terms, avoiding technical jargon, and supports farmers producing 80% of food in these regions per the International Fund for Agricultural Development. However, adoption faces barriers. Only 42% of rural sub-Saharan Africa has reliable internet, per 2025 ITU data, and device costs remain prohibitive for 60% of smallholders. Initiatives like SpaceX's Starlink, connecting 12 million rural users in 2024, and subsidized smartphone programs by the African Union are critical to scaling access, with 2025 projections estimating a 20% increase in digital adoption by 2027. The environmental footprint of AI poses challenges for agriculture's sustainability goals. Training large-scale language models can consume 6 million gallons of water and emit carbon equivalent to 12,000 transatlantic flights, per a 2025 Stanford study. Agricultural AI applications, however, are increasingly efficient, with UC Davis's phenotyping models using 10 GPUs for 8 hours, consuming 0.006% of the energy of commercial models. Edge computing, adopted in 65% of AI farm tools in 2025, reduces energy use by 45% by processing data locally. Renewable-powered data centers, such as Microsoft's solar-powered facilities for agricultural AI, cut emissions by 55%. AI's environmental benefits are significant. Precision irrigation reduces water use by 28%, and AI-optimized fertilization cuts nitrogen runoff by 32%, per 2025 USDA reports. Ethical considerations are paramount as AI reshapes agriculture. Automation addresses labor shortages, but risks displacing workers, with the International Labor Organization forecasting an 8% decline in global farm jobs by 2032. Retraining programs, like the EU's Agritech Skills Initiative, transitioned 15,000 workers to AI system maintenance roles in 2024, with demand for such jobs projected to grow 18% annually through 2035 per a 2025 OECD report. Over-reliance on AI raises concerns about losing traditional farming knowledge, with 65% of farmers in a 2025 global survey expressing worry about system failures. High costs, $130,000 for advanced equipment, risk excluding smallholders, though initiatives like the World Bank's AI for Smallholders Fund, investing $600 million in 2025, aim to bridge this gap. Equitable access requires public-private partnerships, with 2025 data showing 1.5 million smallholders using subsidized AI tools across Africa and Asia. Looking to 2035, AI's potential to revolutionize agriculture is profound, driven by integration with emerging technologies. Quantum computing, expected to be commercially viable by 2032 per Google's 2025 roadmap, could optimize crop rotation and pest management 150 times faster than classical systems. Synthetic biology, paired with AI, could engineer crops with 60% higher yields, addressing food security for 1.2 billion people by 2040, per the World Food Programme. Swarm robotics with AI-coordinated drone fleets could enhance pollination by 45%, countering a 35% decline in bee populations since 2000. The global agricultural AI market, valued at $5 billion in 2025, is projected to reach $15 billion by 2030 per Agritech Market Insights, driven by predictive analytics and 5G-enabled IoT networks. To realize this potential, 85% of AI data centers must be renewable-powered by 2030 to meet net zero goals, and global internet coverage must reach 95% to ensure inclusivity. Ethical frameworks, like the UN's 2025 AI for Sustainable Agriculture principles, will ensure human oversight, with pilot programs in 2025 showing 90% farmer trust in hybrid AI-human systems. By responsibly harnessing AI, agriculture can sustainably feed a growing world while preserving ecosystems for future generations. Like to show your support, comment with your thoughts or questions, and share to spread awareness about AI's role in shaping a sustainable future for farming.